Hello, so in this video we will talk about the memoryless property of a random variable. So by definition, a random variable is x is said to have a memoryless property if the following holds: that probability of x greater than s plus t given that x is greater than s is equal to x plus t. Okay, so then what we do is we check which random variable has this property, and we start with saying that a theorem that x has a memoryless property if and only if it has an exponential distribution. So as a recap, what is an exponential distribution? So we have x is exponential with the property parameter lambda if the PDF is given by lambda e minus lambda x for x in 0 to infinity. Okay, so this is the exponential random variable, right? Okay, but now we have to prove this, that only the exponential random variable can have memoryless property, or if a random variable has an exponential property, it has to be an exponential random variable. So in order to prove this, we will make use of this story here, that if we have a differential equation that y dash over 1 minus y, this is some constant. So how do we do this? We put a minus here, and then we integrate with respect to x, and we integrate here with respect to x. So the numerator is actually the differential of the denominator. So what do we have? Natural log of 1 minus y. This is equal to, and this guy is what? Kx. Okay, so then we can say 1 minus y, this is equal to e to the power of kx, and then we can say y is equal to 1 minus, we have to say minus here as well, 1 minus e to the minus kx. Okay, because if you put a minus here, we have to put a minus here as well. Okay, so then this is the story here, and then we have a constant. We don't have to worry about the constant here. Okay, so let's start now. Let's start with this guy. So we have what? We have probability of x greater than s plus t given that x is greater than s. This is equal to probability of x greater than t. So my first step is I can put a minus here, I can put a minus here. I can add 1 here, I can add 1 here. So this means what? This means this is 1 minus this guy. So this becomes probability of x less than s plus t given that x is greater than s, and this is just 1 minus probability of x greater than t, and we will eventually change it to. So this is what? This guy is probability of x less than s plus t and x greater than s divided by probability of x greater than s. This equals, so what is this? This is 1 minus, so this becomes probability of x less than t. Correct? Okay, so now I can combine this guy. I can say probability of x greater than s but less than s plus t divided by 1 minus probability of x less than s. This is equal to probability of x less than t. Correct? Now this guy I can write it in terms of the CDF. So I can say the CDF of x at s plus t minus the CDF of x at s divided by 1 minus the CDF of x at s. This is equal to fx of t. Okay, so then I can do what? I can bring this 1 minus fx here, and then I can divide by t both ways. So I can say fx s plus t minus fx of s divided by t. This is equal to fx t divided by t. But then I can do one more thing. I can say minus fx of 0. Okay, so our assumption is that our support is always 0 to infinity. 0 to infinity. So then this guy is 0. So I can, if I subtract 0 from anything, I won't change a thing. So then my this guy becomes this guy, and then I'm dividing by t both ways. Then what do? We take limit. So we can say 1 minus, 1 over 1 minus fx of s, limit t goes to 0, fx s plus t minus fx of s divided by t. This is equal to limit t goes to 0, fx of t minus fx of 0 divided by t. So what is this? What is the definition of a differential? The definition of a differential is exactly this. So then we can say 1 over 1 minus fx of s, f dash x at what? At s. This is equal to, this is again a differential at what? At 0. So this is f dash x of 0. Okay, now f dash x of 0 is what? It has to be a constant. So we don't know, but we can say this is some constant. So c. Okay, so then what? Then we have exactly this situation here. Then we have a differential here. We have 1 minus that differential here, and have a constant here. Now note that this s is what? S is a dummy variable, right? So I can write it down again. I can say fx of x prime 1 minus fx of x. This is equal to c. So this means what? This means my fx of s, this is equal to, what is the solution here? 1 minus e to the power of minus c x. Okay, and then what, how do we find the, so this is the CDF. Okay, now what is the PDF? So sorry, or yeah, PD, what is the PDF? This is the differential of this. So fx of x, so this is equal to ce minus cx. Okay, and you can see that if we put c is equal to lambda, then fx of x, this is equal to lambda e minus lambda x. Okay, so this means that we started with the memoryless property, and we proved that if the memoryless property holds, then the PDF has to have this form. Okay, so this is it about a small demonstration about what a memoryless property is and how can we actually prove that the exponential distribution has in fact the memoryless property. So this is it about this video. Thanks for watching and hope you like the video.